Hello, everybody. Hope everyone's doing well after the summer break there. Now, first off, I'd like to just apologize for missing class today. I've been having some trouble with my heating system at home. The baseboards are leaking everywhere. So hopefully, when you're watching this, it's either fixed already or someone's there currently helping me fix it. Now, we're just going to take care of a few things today, maybe do a little bit of algebra review. First, I want to just talk about grading and expectations and how this year might go here. So, of the three files I posted in Google Classroom, I'll be presenting to you about the rules and grading first. If you want to pull it up out of those files, that's fine. If not, I'm also going to present it and you can just see it up there. All right, now at the top of the document, you see Wednesdays. Wednesdays, you don't have class. uh, we'll be here unless you guys come back to school, and then not if not, we'll be at home while they're cleaning. Either way, I'm going to be offering help at 10 a.m. to 11 a.m. and from 1 p.m. to 2 p.m. Now you can just email me and tell me, hey, I need help. I'll start a Google Meet and I'll send you the link. There might be more than one of you in there. Everyone I have this year is trig though, so it should go okay. Also, in addition to that, on Mondays, Tuesdays, Thursdays, and Fridays, we have from 8:15 till 9:30 or so, where we're supposed to be dealing with the remote stuff and helping. So if you do need help during that time, all I ask is please just let me know the day before so that I can make sure to get everything else done so I can help you during that time. Now, for the grading, just like every math class you've had up here, 20% for your homework, and we'll talk about that. 30% for quizzes, and we'll see how those go. Maybe I'll give a few of those on Castle Learning. We'll see. And then 50% tests. And we'll have to see how everything works out with the whole school closing thing. If we end up coming back, we'll knock those off in school, maybe. Well, we'll try. If not, if we do end up staying remote longer, we'll just figure it out as we go. Everything, though. Everything will be handed in through Google Classroom. I don't want you to type stuff out. Typing math out is really annoying with exponents and functions and everything. So you can just write stuff down, take a picture with your Chromebook or with your phone, and then just submit it through class. And if you need help doing that, I'll be more than willing to help. Like it says, if you have a printer, print out the work if you want and have it right there in front of you to look at, and just take a picture of it. Or if not, you can just write it on a separate sheet of paper. Now, the plan here is to do a unit just about every 2 weeks. Let's try to stick to mostly the basics for this year. Maybe cut out some of those word problems from the Common Core that you've seen on Regencies in the past. Uh, we'll do our best to get as much done as we can. At this point, they haven't officially canceled Regencies, but I mean, can't imagine that they would have them with the way things are going. But we'll see how things develop as the year goes. Maybe we'll pick it up and do harder stuff. Uh, like it repeats here, Wednesdays we have time, and in the morning from 8:15 to 9:15 to 9:30 or so, we have time. And like it says at the bottom, we just want to do as much as we can. Try to get you ready for pre-calc if you're going to take it. If not, we'll just do what we can do. We don't want to make this super stressful and make things worse than they have to be. Well, now we're going to actually talk about some algebra here. And like it says up at the top of this screen, technically this class isn't really trig. There's not much trig in it, only about 2 or 3 weeks. It's always been called trig in the past, so a lot of people still refer to it as that. If you were to get a Regents for this, it does say Algebra 2 Common Core on it. So we have to know a lot of algebra. That's what we're going to start out with first. Now, we just have a few notes, very brief amount of notes, and then we'll go on. Now, I have one of those new fancy Promethean boards, not that you can see it right now, but it's a few feet away from my desk and the laptop here, which I can't move because of the whole bunch of cords they have. So I have to keep getting up and going over to it, and hopefully I won't trip when I'm recording myself because I really don't want to have to do that first part all over again. So I'll try to talk as loudly as I can when I'm at the board. Now, first thing we're going to review from algebra, some of the basic exponent rules. The first one, power to a power. When you raise an exponent to another exponent. Now, the way you do this is you are going to, and these technically you're already supposed to have memorized. If you don't have them memorized, we will work on them a lot, especially in the beginning, because you do still need them in the middle of harder problems. So make sure you learn these. When you raise a power to a power, you're going to multiply your exponent. And when I write these notes down, I mean, if you have a notebook going on, this is what you should be writing down as reference for when you're trying to do the work. Like I said, we will keep practicing with these, but so power to a power. Multiply the inside exponents by the outside exponent. Power to a power, you multiply. If you're multiplying x's, or g's, or w's, or y's, or any other variable, you multiply variables. Same variable. You add the exponents. So power to a power add. If you're multiplying x's, excuse me, power to a power, you multiply. You multiply x's, you add. There's one more, dividing x's. Or any other variable. And hopefully you're thinking in your brain here what this is going to be. And hopefully, you can think about it. If you multiply x's, you add. Dividing is the inverse operation, so subtract. Hopefully, you've got that all written down, and this is starting to come back to you a little bit here. People always seem to have a trouble remembering this. You're supposed to know it even before algebra, but especially after algebra. So if you don't have these memorized now, you got to try to remember them. You got to try to keep them memorized. We will, like I said, we will practice with them to try to, drill it into your brain here. Hopefully that'll help. And we'll do some examples now. And these aren't all entirely the exponent rules, but some of them are. Hopefully all this seems familiar. Now again, I'll try to speak up as I'm over at the board for you. Number one, x plus 3 squared. Now this is a binomial squared. Binomial terms. Terms are separated by pluses and minuses. Now, unfortunately, I can't just say x squared and 3 squared. Hopefully you remember this. You have to write it out twice. You might not have to if you can do it in your brain, but I'm just saying the process. It's like you're writing out twice. Now, hopefully, this looks familiar. Usually everyone remembers this. Maybe your algebra teacher called it double distribution. Maybe your algebra teacher called it FOIL. But we'll distribute the x, and this is multiplication. X times x is x squared. Now I go to the 3x, and everything's plus in this one, so it's nice and easy. Now I've distributed the x, now I do the 3. So, plus another 3x, and then lastly, 3 times 3 is 9. Just be careful. Some people sometimes will add those, they see 2 plus signs, and for some reason they just write a 6 down or whatever the question would have there. Just be careful. What we can add, what we can do is combine the middle two terms. 3x plus 3x is 6x. And that one is done. And again, I'm sorry for not being here. If you have any questions on these, you can ask me next week. Then I'll give you a week on all the homework assignments and everything, so you have plenty of time to get help. Now, the second one. Ironically, the second one should have been earlier in your school career and easier than the first one. But it seems to me lately more people have trouble with this than double distribution. Now there's no pluses or anything, there's no distribution. This is just straight out order of operations. PEMDAS, P for parentheses. Well, there's nothing in the parentheses to do. E for exponents. Now I have that 2 outside of the parentheses. We're going to raise a power to a power. And if you flip back to where you wrote stuff down, then you'll see that's the first rule we went over. Power to a power, you multiply. Just don't forget the big 3 in the parentheses, the regular number, the coefficient 3. That has, like every other whole number or any variable, if it doesn't have an exponent written down, it's a 1. So the inside exponents times the outside. For my base of 3, 1 times 2 is 2. For the x, 3 times 2 is 6. Well, 3 squared, that's a number. I can do that. 3 times 3 is 9. Now I'll bring down my 4x squared. This is just multiply. 4 times 9 is 36. And if we think back to the notes that we just took, hopefully you think, multiplying variables, I add their exponents. 2 plus 6 is 8. So that one is all done. Now, number three. Number three should probably look a little familiar, kind of the same type of question as number one. Again, you can't just square each one of them. We got to write it out twice. You can't do it in your head. Do the double distribution. 5 times 5, 25. Now, the reason why I asked this question, when there are numbers in front, sometimes people will just write the variable, like b. Don't forget, it's also b squared here. When there's a number out front, don't forget to square on your variable. Now the rest of it's pretty much the same. 5 times 2, 10b. Now we distribute the 2, another 10b. And then plus 4. Again, the middle two numbers, we'll put those together. 10 plus 10, 20b. Now I'll give everyone a minute to catch up here, although I suppose you could just hit pause. Number 4. On number 4, the 2m squared q cubed has no plus or minus. So this is not what we just did. This is not a binomial times a binomial. This is just single distribution. This one in here, show you, if you have more than one variable, just do it one at a time. It's the same idea. Two times 4 is 8. Just again, don't forget that that m in the parentheses has an exponent of 1. So 2 plus 1, because we're multiplying, add the exponents, m cubed. For the q's, 3 plus 2, 5. Bring the minus down since there's no other negative to make it a double negative. There's no coefficient, so we'll bring the 2. There's no m, so we'll bring m squared. We'll bring 2m squared with us, but it stays the same. This q also has a 1 exponent. 3 plus 1, q to the 4th power. And you're done. You can't put those together. They do not have the same exponents. Now, number 5, again, it's a pretty similar question. Basically the same thing here. We'll distribute, it's just single distribution. Negative 3 times 5, negative 15. W, we have a 4 to 3, we're multiplying, so we add the exponents. W to the 7th, x to the 3rd. Again, remembering that there is that 1. Now, on number 5 here, I just wanted to work in at least one. We have on the next arrow, a negative times a negative. Don't forget that double negatives. We'll switch it to a positive. So plus 1 times that whole thing is just that whole thing. Like I said, When there's multiple variables, just go one letter at a time, one variable at a time. Try not to let it confuse you. Just take it one step at a time. Well, number six. Number six is multiplying polynomials again. This time, though, what's different than the first page is that the second is a trinomial. And you would have seen this in Algebra 1. It might have even had been on your Regents. It's just more work. It's the same idea, but it's more work. So we'll distribute 2 times 5, 10x. Now just don't forget we're multiplying, so you're going to add those exponents. That'll be x to the fourth. Minus 3 times 2 is 6. Again, we got a little 1 there. You don't have to write those down all the time. I'm just trying to help you remember that they are there so you don't miss them ever. That'll be x cubed. And then 2 times 2 for x squared. Now we'll distribute the 3x, and again, there's that exponent of 1. So plus 15x cubed minus 9x squared plus 6. Like I said, it's the same idea, but it's just more work. There is more distribution that we've done, but now there's also more work combining like terms. Now, I just said like terms, what does that mean? Like terms that you can add or subtract, terms you can combine, have to have the same variable. Well, they do, they're all x's there, but they also have to have the same exponent. There's no other x to the fourth, so I just bring down that 10x to the fourth. Or negative 6x cubed. We have to match that with a like term. So we'll match that with the 15x cubed. So negative 6 plus 15 is 9. And again, you don't have to do the little cross outs that I'm doing. I'm just trying to help you keep track of ones that we have already used. 4x squared matches with the 9x squared. 4 minus 9 is negative 5x squared. Bring down the 6. That one's done. I mean, I would imagine most of you probably wouldn't have thought that was too difficult. Like I said, that could have been right off your Algebra 1 Regents. Number 7 now. Number 7, we got 2 trinomials. So this one is a little bit more involved. This is one that would have been on this year's Regents, the Algebra 2 Regents, the trig Regents, whatever you want to call it. This is a little bit more work, more to keep track of. I'll try to color code each distribution. Here we go. So we got to distribute that 6y to the fourth first. Six times 5, 30. Y, add the exponent 6. Minus 2 times 6, 12. Y to the, don't forget the 1 that isn't there. So fifth. Minus 6 times 6, 36. Y to the fourth. Now I got to distribute that negative, the minus 5y cubed. So minus 25 y to the exponents 5. Oh, double negative again, plus 5 times 2, 10. And again, there's a 1, so y to the fourth. Double negative again, plus 30y cubed. Now, this is more work because we still have that plus 2y in the first parentheses set that we have to distribute. So, plus 10y cubed minus 4y squared minus 12y. All right, well, let's see. For combining the like terms to finish this question off. There's no other y to the sixes. I'll just bring that down. I got my negative 12y to the fifth. I matched that up with minus 25y to the fifth. Minus 12 minus 25 more is minus 37. For my y to the fourths, negative 36 plus 10, negative 26. So minus 26 y to the fourth. Y cubes are right together already. 30 plus 10 is 40. And then the other two you can't do anything with, just bring them down to the answer. Well, I hope everyone still with me and has made it this far through the video and doesn't just give up. I imagine most of you thought that one was maybe a little bit of work, but doable at least. Like I said, that the one like that could have been straight off of this trig regions, this algebra 2 regions. They ask them if they have whole numbers. They usually ask them in multiple choice. If they have fractions, they have them on the written out part usually. Anyway, not too many left here. Number 8. Maybe this might look familiar from y equals mx plus b in geometry and algebra. Can't justify either the 10 or the 15. You have to do both. So 10 over 5, 10 divided by 5 is 2x, plus 15 divided by 5 is 3. Easy. Just trying to remind you, you have to divide both. Now 9 looks kind of the same. You didn't really have this pop up as much. Maybe for your slope. If you're graphing a line, you'd have to use a fraction. But here, you can't divide either the 3 or the 9 by 15. So what we'll do, we got to divide all of them by the same thing. We'll ask ourselves, what can I divide a 3, a 9, and a 15 by? Well, that's 3. So I'm going to divide all those by 3. And you wouldn't have to all that. I'm just trying to make everyone see what's going on here. 3 divided by 3 is 1. Well, we have x. We could write 1x. It's the same thing as just x. 9 divided by 3 is 3. 15 divided by 3 is 5. Done. Something like that we'll have to use a little bit more when we get to something called imaginary numbers, which sounds silly, but well, you'll see later. And a radical chapter on square roots. Now, 10, speaking of square roots, 10, you might have seen stuff like this in geometry when you're talking about perimeters or maybe Pythagorean theorem, simplest radical form. 3 is a prime number. You can't break that square root down. It's already in simplest radical form, but the fraction overall hasn't been simplified. Now, the only reason I have this one up here, 10 divided by 2, that's easy. 18 divided by 2, that's easy, hopefully. But just don't touch that 3. You got a number with a radical and a number without a radical, you can't do anything. So we're just gonna, and maybe your teacher in the previous years told you, once you break a radical down, the simplified radical is kind of like a variable. You're not gonna really do much with it, unless there's another radical, but we're not worrying about that yet. So anyway, all we're gonna do is the 10 and the 18 divided by 2. Don't touch that square root, just bring it with you. 10 divided by 2 is 5 plus 18 divided by 2 is 9. Bring the radical 3 with you. Now, actually, I think now that I've done that, that was, I forgot to mention, that was the file that I posted in Classroom under notes. Maybe you already saw that, maybe you didn't. If you wrote this stuff down, you don't have to open that, I guess, then, if you hadn't. What I did with the rest of the class for the classes I did have this week, we spent the rest of the time working on homework. Now I let them work on it. I just wanted to make sure everyone could figure out how to take a picture of their work, submit it on Google Classroom. When we did remote learning last year, I had a lot of people that did that. Everyone seemed to figure it out pretty well. What you can do if you want to use your phone, log into Google Classroom on your web browser, take the picture, and then when you go into the assignment and you have to add the file, go to upload on your phone. That should be easier to find, and most all of you send pictures and stuff to social media and everything. You should be able to do that. If you do want to use your Chromebook, now this might look a little bit different than your Chromebook. I know yours might not be touch screen. To find your camera, you gotta get this to come up and then expand this up to see all your apps, all your programs. You got camera. Take your picture of your assignment, then go into Google Class, go to My Class, go to the assignment, go to, when you go to add the attachment, then go to upload, and I believe it'll be on the upper left-hand side of the box that pops up, and you have to go to images. That's where it stores, I believe, everything that you take a picture of. It should be in there. Like I said, though, I mean, you have a week to submit it. So if you have trouble taking the picture and uploading it into Classroom, don't panic. Just get a hold of me next week sometime. We'll make a meet and I'll help you with it. No worries. I understand. So that being said, it says right in Google Classroom when it's due. Try to get it in as soon as you can. Just make the attempt in case you do run into trouble uploading it. And also, as well, again, I'm sorry for not being here today. I know it's bad missing the first one, but uh, yeah, I had to get that problem fixed. I have to have part of the floor removed in my house too. So anyway, hope everyone, this worked well for everybody. I'll see you next week on the meet, and we'll see what happens after that. Take care, everybody. Thank you.